All right, so in question 5, we are given a pill shape made up of 2 hemispheres and a cylinder in the middle, and asked to find the surface area and volume of this figure. So in order to find the surface area, we can find the surface area of the hemisphere, and then the surface area of the cylinder, and then kind of roughly add those surface areas together. So the formula for the surface area of a hemisphere from our notes is 2 pi r squared plus pi r squared, and then the surface area formula for the cylinder is 2 pi r squared plus 2 pi rh. But here we have to remember what each piece of these formulas represents in the figure, because we're going to need to modify this formula. Because if you have a cylinder by itself, then this circle right here would be the top, but the top of the cylinder is being covered by the hemisphere, so it doesn't count towards the overall surface area of this pill shape. Similarly with this circle. So looking at our hemisphere formula, that pi r squared at the end is the area of that circle, so we don't want to include it in our total surface area formula. Similarly, the 2 pi r squared from the cylinder formula represents the top and bottom, so we don't need that. Also, our composite figure has 2 hemispheres, one on the top of the cylinder and one on the bottom, so what we're going to have to do is we're going to have to count that twice. So for the pill shape, our surface area formula is going to be 2 times the 2 pi r squared, so 2 of the curved surfaces of the hemisphere, plus 2 pi rh, which is the curved surface of the cylinder. And then we can plug in our values. Whoops. So the radius of both the cylinder and the hemispheres is the same, so we can plug in 6 for r in both of these cases. And we're given that the height is 11. So plugging all of that into a calculator, we have that this total surface area of this pill shape is 867 and some feet squared. The answer then, rounded to 3 significant figures, is going to be 867 feet squared. For the volume, we have, if we just take the volume of the hemispheres, 2 of them, and then add the volume of the cylinder, then we're good. We don't need to modify these formulas because volume is a measure of the interior space, and no matter how many shapes you put together, the amount of space they have inside doesn't change. So we have 2 of the hemispheres, so 2/3 pi r cubed is the volume of a hemisphere. And to that we're going to add pi r squared h, which is the volume of the cylinder. So plugging in the values we're given for the radius and for the height of the cylinder, we get that the volume in this case is 1,556.172575 feet cubed. Volume is a 3-dimensional measurement, so our units are always cubed. Here we have 1,560 if we want to round our answer to 3 significant figures. And that's question 5. Question 6, we are given a house shape made up of a triangular prism and a cuboid, and we are told that the triangles shown are isosceles. What that means is we can assume that this side of the triangle and that side of the triangle are the same lengths. So in this problem, our strategy to find the surface area is going to be to find the area of each of the shapes on the outside and then just add all those areas together. So we can use some colors to help us. This house is made up of 2 rectangles for the left and right sides of the house. We can see the right side, and we're going to color code that in pink. There's a front of the house, which is this rectangle right here, and there's another rectangle in the back. Then the house has a base on the bottom that we can't see. We'll color code it in yellow. The roof of the house is made up of 2 triangles, one in the front, one in the back, and also the slanty part of the roof is made up of 2 rectangles. So, to find the surface area, we can find the area of the 2 triangles and then add the area of the 2 roof rectangles, and then the 2 rectangles for the front and the back of the house, the 2 rectangles for the left and the right of the house, and then we have just the 1 rectangle for the base. Just to keep our color coding consistent, so the orange is for the front and the back, and that yellow is for the base. All right, so there's our formula in shapes. Now we can just add numbers to this. So the formula for the area of a triangle is 1/2 base times height. So we're given that the height is 5, so we'll have 1/2 times 5 times the base is 14. For the blue triangle, we've got 2 of those. We know that 1 dimension of the blue triangle is 9, but notice that we're actually missing, we don't know this dimension right here that I've colored in red, so we have to find it. And this is where assuming that the triangle is isosceles is going to come in handy, because what we're going to do is we're going to drop a perpendicular to the base of this triangle, and then use this right triangle to help us find the missing dimension of the blue rectangle. So in this right triangle, we know that the height is 5. Because the green triangle is isosceles, when we split the bottom, we cut it perfectly in half. So the whole length was 14. So for our right triangle, the base is 7, and we're trying to find the hypotenuse of this right triangle. So using the Pythagorean theorem, we have 5 squared plus 7 squared is equal to x squared. So 25 plus 49 is equal to x squared, and we have 74 is equal to x squared. So to get x by itself, we will square root both sides. We only care about the positive answer because we're talking about measurements. So we know that x is going to be approximately equal to 8.6023. I don't want to round to 3 significant figures in this case because I'm not done with the question, but I don't need to write out all of the measurements in order to have, in order to be able to approximate my final answer to 3 significant figures accurately. So I'm just going to round that. So now I know that the blue rectangle is 9 by 8.6023. And then the rest of the rectangles, we are given all the measurements. So for the pink one, that's 8 times 9. For the orange rectangle on the front and back of the house, that's 8 times 14. And the base of our cuboid is 14 times 9. The reason we only have one of these yellow rectangles is because notice the top of the cuboid is actually covered by the triangular prism, so we're not going to count that towards the surface area. Once we have that formula written out, that's the hard part. Now we can just take that and plug it into the calculator to find that the surface area is 718.8414 inches squared. Rounded to 3 significant figures, that gets us 719 inches squared. And now the volume of this house means we're going to find the volume of the triangular prism. And add to it the volume of the cuboid. So V equals, the volume of the triangular prism is going to be to find the area of the base and multiply it by the height. In this case, our triangular prism base is the green triangle. So that's 1/2 times 5 times 14 is the area of the triangle. And then the height of our prism is actually this length along the roof. So that's 9 inches. So there's our formula for the volume of the triangular prism. The volume of the cuboid is just take the 3 dimensions and multiply them together. So that's 8 times 14 times 9. And if we plug all that into the calculator, we see that the volume is 1,323 inches cubed, which rounded to 3 significant figures is 1,320 inches cubed.